There we go. Okay, excellent. Hello, everybody. My name is Ryan Emberling, and my talk today is called Real-Time Talk, Testing Multi-User Interactions with Cypress. So who am I? I'm the Director of Engineering at a small ed tech nonprofit called the Assessments Foundation. I'm the creator of a full-stack PvP implementation of my favorite card game that's called Cards, and I love open source software, very much including Cypress. So today we're going to be talking about how to test application flows that have multiple users involved. And as we do that, we're going to start by sort of setting the table with respect to our test philosophy and the general approach that we want to take based on the specific requirements of our organization, essentially. And we'll look at different ways that users can interact with each other essentially through software and use that to frame our understanding about how we want to approach our testing. And we'll look at 3 different flavors of multi-user testing. And then we're going to dig into some of the technical requirements for how to test applications with multiple users across these different techniques. All of them have some elements in common, but they get implemented differently based on sort of the assumptions and the environment that you're testing in. And then we're going to look at those in practice with 3 contrasting demos of real tests that are used to test multi-user applications in each of these 3 techniques, with some look at like why I'm taking that particular approach for these different applications. So when we're considering like our philosophy and sort of our approach towards testing multi-user flows, the first thing that we need to consider is the actual application flows. And there are different flavors of this. How many different kinds of applications are there, and how many kinds of users are there, and what are their experiences? Are we looking at a single experience, like a chat application where there's one product and different users are interacting with each other? Is it real time or is it asynchronous? And then we also need to consider some of the environmental constraints with respect to our testing environment. Do we have a need to mock, for example, and which aspects do we need to mock? Are we sharing our test environment with sort of like the entirety of the development team, or is this an ephemeral environment that's isolated to the particular test run that we're doing? All of these can influence some of our decisions, assumptions, and the associated risks and advantages of our testing approach. And then we need to define and consider like which functionality is most important to our business, and use that to inform, again, our understanding of risks and assumptions. What kind of approach do we want to take towards testing, and what does that say about our confidence with respect to what we know works and where there's still uncertainty, and how can we live with ourselves and our tests with what we do and don't know about our application based on what our tests are telling us. So in order to demonstrate different kinds of multi-user flows, I'd like to contrast my professional work at the Assessments Foundation with my open source project of Cards. And in particular, the Assessments Foundation has generally asynchronous pull style updates and asymmetric experiences. And so by this, I mean that generally users need to refresh the page in order to see data that was updated or generated by another user previously. And by asymmetric experiences, I mean we have different kinds of users who are interacting in interrelated flows. So for example, teachers will create homework assignments or formative assessments that they'll deliver to their students, and then students interact with that data by actually completing their homework. We hope they complete their homework, right? We like it when the kids are actually learning math. And in contrast, in Cuddle, the updates are push style, meaning that this is real-time updates. When one player makes a move, the other player sees the result immediately. And these are a symmetric experience, meaning there's like a single client application, essentially, and a single kind of user. And so there's really only one product that needs testing, but we need to be able to test that when somebody else does something, that we as the user viewing our version of the client see what we need to see. So to give a little more context about these async examples, I'd like to just walk you through some of the essential components of assessments. This is perhaps the most important aspect, and this is the student experience. Here we see a student working on their math homework, and they're prompted to answer a question, and this is part of several questions that all go together in the assignment that their teacher has given to them. So in order to even arrive at this experience, a student has this prerequisite where a teacher needs to have created an assignment and deliver that assignment to the student through their class. And then once this student and perhaps others in the class actually complete their work or as they go, that creates data on how the student did, what they got right, what they got wrong, when they were requesting hints, things along those lines, which then the teacher is able to view on an interactive data visualization. And this shows things like which students are struggling the most, which problems are the hardest, which Common Core standards are the ones that the class seems to have down versus need additional practice in, and which answers are commonly given that are incorrect, for example. And all of these, the teacher can use to guide their instructional decision-making, essentially. But it's notable that these different asymmetric experiences are all happening within a broader ecosystem of different users interacting with various applications in ways that are all sort of interrelated, and again, for us, asynchronous. So the starting point here is our content authoring system. So we have staff as well as some teachers who will build math problems and organize them into digital worksheets that we call problem sets. And then teachers can go and take those problem sets and assign them to their students, at which point the students can complete their work. And then the teachers can see these reports that we just looked at, as well as some others regarding how students are doing, which things they should focus on, basically, based on how the class did on their homework. And we additionally have district administrators who are able to view that same data generated by both the teachers actually and the students, but at this aggregate scale where they might look at which Common Core standards across an entire curriculum for a whole district over a school year is the school struggling with, and use that to inform district policy or professional development, things along those lines. So all of this is in an interrelated ecosystem using these pull style updates, meaning that a teacher creates an assignment, at which point a student is able to go to to view that assignment, essentially. And when a teacher is viewing a data report, the page loads essentially at the time that the teacher views the page, and that'll show them all of the data that the students have completed up until that moment in time. And so this architecture at the application level lends itself to a couple different ways that we could frame our thinking about testing. One, and this is the most common and what we do the most at assessments, is to test each of these applications individually in what I call a single view async approach to testing multi-user interactions. And here the general idea is we're going to seed and or mock anything that is prerequisite to the flow that we're trying to test. And then we will test the individual experience through the user interface for the particular experience and flow that we're looking at. So we can, for example, seed problems and problem set data from the content authors while we're testing the teacher experience, and then verify that the teacher is able to use the user interface in order to create assignments that have the various configurations that they need. And we might do a similar thing at the student side, where we would treat assignments as a prerequisite that are seeded in order to test that the student is able to complete their homework, essentially, when it has a particular configuration. And this works really well and has, in particular, I would say, two advantages. One, that it's very efficient to write and to maintain a full breadth of coverage across various combinations of flows and experiences, like within a particular product, by just seeding whatever data that you need as a prerequisite. And it additionally gives you very fine-tuned and precise signal when there's a failure into which product and which part of the experience is having the issue in a way that's very easy to tell at a glance. But it does come with some risk, namely, what is happening in the gaps between each of these products, essentially. There are various ways that you can mitigate this risk and essentially increase your confidence that whatever we mocked and or seeded at the student experience level when we were treating the teacher's data generation as prerequisite, that really is exactly the same output as what the teachers generate when they are creating those assignments through their experiences. You can do this with API testing or a number of different ways. But one that I'll put forward as worth considering as well is what I call a multi-view asynchronous test, where you can test multiple perspectives in the course of a single test flow, essentially. And so here, what we can do is create an assignment as a teacher and then complete it as a student, for example. And this has some disadvantages. In particular, it reduces the test signal and the sort of precision. If there's a failure in a test that started by creating an assignment and then did it as a student, is that failure a problem with the teacher experience or the student experience, for example? And likewise, it can be a little bit more cumbersome and a little bit harder to maintain tests that work this way. And so generally, it isn't always the best fit for the full range of complexity of all the different test flows that you want to ensure work at your organization. But for us at Assistments, because of the business critical functionality of the teacher and student experiences working together seamlessly so that teachers can create a particular assignment configuration that a student can then do in exactly the right way, and that these two systems behave together exactly as we want them to, we have decided that it makes sense for us to do at least a small amount of basically happy flow testing to ensure that these two experiences work together seamlessly. And so our overall strategy is a combination of predominantly single view asynchronous tests of each individual experience, seeding the prerequisite data, which I think is generally considered the best practice, with additionally some multi-view asynchronous testing, just to confirm that the absolutely essential functionality works between the teacher and the student experience fully end to end. And that gives us the highest degree of confidence that the most critical functionality is working flawlessly. Now, in contrast, Cuddle is a real-time application. And so here we have two different users who have sort of the same role and relationship to the platform, and they're using the same client and generally the same experience, that are interacting directly with each other, and here in real time with these push style updates, meaning as soon as one user makes a move, the other one is updated of it, and vice versa, without having to refresh the page. And this symmetry of the experience lends itself very nicely to testing these perspectives individually in a given test flow, which I call a single view real-time test, meaning we'll take one perspective and treat a given user as the sort of active user from whose view we are experiencing the test. And then any of the other actions that are taken or that this other user is sort of interacting with will be simulated directly via API requests, at which point we can make our assertions about what's happening. And so with that, let's talk about some of the actual requirements and sort of mechanics for how we go about testing with these different architectures and philosophies for testing multi-user interactions. All of them have some essential components that are shared across them with separate implementations depending on your approach. So first and foremost, you need a strategy for user management. How are you going to authenticate each of your users? How are you going to make sure that you are able to take actions on behalf of one user at one time and another user at another time? And are you doing this sort of through a page load of some kind, or are you doing this with API requests under the hood? Then you'll need a strategy and an implementation of automating and your common actions, essentially, the things that your users do. And here you're basically writing Cypress commands, which can take the common operations that you need done and streamline the process of writing tests essentially into these more concise, discrete chunks that are able to fully express the range of things that you want to check that your users are able to do. And then you need a mechanism for state validation where you actually confirm, did the right thing happen? And based on the approach to testing that we're taking across these sort of asynchronous, synchronous, and single versus multi-view philosophies or approaches, we'll have different implications for like how we can go about user management, action automation, and state validation. So for user management, there are a few different techniques that that you can use. One is to use sci.request essentially to seed and or simulate the interactions of some unseen user as you go, basically, either as prerequisite for your test if you're talking about an asynchronous situation where you just need data generated as a prerequisite of your test, or during the course of your test cycle if you have got a real-time situation where you're trying to test that in a moment when another user makes a request, say to send a chat message, that appears immediately in the DOM. You could alternatively simply authenticate the current view, take some steps, and then authenticate a different view. And this is really that multi-view approach to multi-user testing. Or you could use a dedicated connection, like if your application utilizes WebSockets the way that Cuddle does. This is another approach that you can use for managing separate session data, essentially. Now for action automation, first, you always want to come back to your overall testing philosophy that you're taking within a given flow and use that in order to create like a general strategy for how you're going to automate your actions. What's happening through the UI versus the API, at which point you can start applying it to separate situations to manage all the sort of common operations that you need to be able to test. And state validation comes down to the kinds of things that you want to assert and what do you care to verify basically after either the current user you're looking at or perhaps an unseen one is taking their various actions. And you can validate data in the database, in the API, which itself can be indicative of what's in the database, in the DOM, or in client-side state. So on this one, for example, in Cuddle, we use a small little trick to basically expose the Pina stores during testing to Cypress via the window object. And this lets us grab the actual application state directly off of the window object at test runtime to make assertions about the state of data, which doesn't necessarily correspond to a particular DOM node at this time, but which is relevant for the ensuring basically that everything is functioning correctly. So with the table set, as it were, with respect to what these different approaches to testing multi-user interactions are, and some of the overall technical requirements and general techniques for how we could apply those, let's take a look at examples of single view async, multi-view async, and single view real-time testing in the assessments and Cuddle contexts. So for single view asynchronous testing, let's remember first and foremost that we're dealing with pull style updates, and we're going to test each experience individually, meaning our general strategy is to mock any data that is prerequisite essentially of the particular flow that we are testing. So for the teacher experience, we will be seeding data around the existence of content that we need. From the student experience, we will be seeding the creation of assignments. And once our data is seeded, either directly via like data that's written into a prefabricated database that we can depend upon, or at test runtime via API calls, we're going to make our actual interactions with the application through the user interface, and then we're going to verify that data is correct through the API. And one of the key pieces that is going to help increase our confidence that our different single view asynchronous tests are working together correctly, and increase our confidence that the gaps essentially between these products are working, is the use of shared fixture data across the sort of asymmetric experiences of teachers and students in this case. So for us at Assessments, this means a definition of certain assignments that we want to generate at test time, which most importantly will specify which problem set, like which digital worksheet is being assigned, and then various settings, which can include, for example, a time limit, or whether to show students if their answer is correct every time they submit the answer to a question, whether to show them the report at the end of the assignment, things along those lines. And this same definition of a fixture can be used by the teacher experience, on the one hand, to effectively define, this is the kind of assignment that I want to make. Can I make an assignment that correctly adheres to these to this configuration? And on the student side, to say, okay, let's programmatically generate and seed an assignment of the following configuration as a prerequisite to the test. And then from there, let's make sure that the student can complete an assignment that matches that configuration. So on the teacher side, I mentioned that we want to use these fixtures to effectively confirm that the teacher experience is capable of making an assignment that meets certain criteria using one of those fixture definitions that I showed you. And our general strategy here starts by intercepting the app's API request in order to generate an assignment. And here we're not intercepting to mock, actually, because we want to ensure end-to-end that the full application works, but rather only to uncover basically the response that the server sends to the application's request, because the request is going to be triggered by the UI, not by Cypress itself. Then we go through the user interface, clicking on buttons and filling out the form in order to create an assignment based on the definition of the fixture. And that means that we'll dynamically set various fields based on the fixture, including toggling switches or filling out form fields. And then lastly, we'll verify that the assignment that is generated by the application actually matches the description of the fixture object. And that's really the motivation for this initial intercepting of the application's API request. Let's take a look at this command. So the basic idea is we're going to input which course we want to assign to, and then an assignment fixture that includes like what problem set am I assigning, and what settings do I want assigned. And then here is where we do that intercept call that I mentioned earlier, which fundamentally allows Cypress to grab the response of an API request, which is not itself controlled by Cypress, but rather by the application. Because what we're going to do here is click through the form. And so that means that the app itself is going to send an API request to generate a new assignment. And then once that's done, we want to get the response to that API request to learn the ID of the new assignment that was just created. And then we can use that to verify that the correct configuration essentially has been established. So once we've spied on the API request, we're in a position to go to the right page of the application where you can assign, and then to start filling out the form essentially and describe the assignment, filling out which problem set we want, selecting the correct class that we want to assign it to, and then we start dynamically filling out some of the settings. I'm skipping over a bit of the guts of this command because it's a fairly large form with a bunch of fields, but the general idea is that based on specific configuration of the fixture, we will turn on certain settings or not. And interestingly, I was thinking about this during a previous talk regarding like deliberate use of effectively dark patterns. Like we talk often about conditional testing is a little bit shaky. And so if clauses are always something to be suspicious about. But here our motivation for conditional testing, or rather conditional interaction, is basically so that we have a command which can express for any given configuration of assignment settings, can we click on the right aspects of the form to put them together and generate an assignment that matches what the fixture says. And so we'll dynamically click through the form, toggling the right switches and filling out the correct text boxes and all that sort of stuff to match the fixture, at which point we will submit the dialog. And here is kind of the secret sauce where we make use of the sci.intercept call on the first line, because, or the very beginning of the command, because that intercept call aliases the application's API request to generate an assignment, which then we can make assertions on and make use of. And in particular, what we can do is grab the identifier of the newly generated assignment, which isn't known by the test previously at runtime, right? Because it's just generated by the application's API request. And then we can use that to validate that the assignment that was created just now, whose ID we just spied on, actually matches the description of the fixture. And we do that with this verify assignment definition command, which essentially inputs the ID of an assignment that is expected to exist in the backend. And then we input a fixture which describes the shape, right? And this should match once we make a GET request for the specific assignment. And of course, that's supposed to 200, because the assumption here is we just created an assignment. Here's its ID. Let's go get it and make sure that all the properties match. And then we start walking through the various attributes of an assignment and verifying that all of them match what was described in the fixture object that we used to dynamically fill out the form. And once we've done that, we can loop through the assignment settings, which itself is a dictionary with different setting names and values, and effectively verify that for any given setting that was specified in the fixture, that the actual assignment that was returned by the API when we made a GET request for the new assignment has the same value for that setting, essentially. All this together lets us write fairly concise tests where, like, the key, like the guts of the test is basically just the fixture definition. And now we can quite concisely write a test that verifies that you can create an assignment with a time limit by specifying which class I want to use and an assignment fixture definition, which really minimally just needs whatever sparsely populated attributes of the assignment I want to make sure work together, essentially, and that I can fill out the form in order to create. And with this, we can start cranking out many tests very quickly by just generating different fixtures, essentially, and calling the same command with those different combinations. And because there's actually logic around which fields are like valid with which other ones, and there have been interactions in the past where it seemed like things should work together and didn't, we want to be able to verify that the form can be used to create an assignment of any given valid combination. And we can use our fixture data as the main sort of thing that needs to be written in order to express whether the application can create an assignment of that kind in test code. So let's put all that together and just see how that one simple test runs. Here we see we quickly navigate to the actual page with this content. We start filling out the form dynamically. We set a time limit to 2 minutes. We assign it to our class. And then at the end, we go to the page where the teacher can see their list of assignments. We verify that the newly generated assignment appears in the list. And then beyond that, we make this API request directly via sci.request to get the assignment with that verify assignment definition, and confirm that every single property in what the API says is, here's the new assignment you just made, matches what the fixture said should have been created. So now reciprocally, or complementarily, we want to be able to test that the student experience can make use of those assignments. But for the purpose of having a robust combination and across the possibility space of all these different permutations of settings that have different implications for what the student experience is supposed to be, we want to decouple the actual runtime of that previous test where we generate a particular assignment from the runtime of the student experience test where we execute on a specific assignment. But we also want to make sure that those things like link up and align with each other. And our technique for doing that is basically to use the exact same fixture object in a corresponding test. So we then take the same assignment fixture that specified, can I generate an assignment which has a time limit of 2 minutes, for example, and then we use this command to just make an API request on behalf of the teacher in order to seed the existence of that assignment. And we can then sort of compose that in a slightly higher order command that's actually used in the test, which will first generate the assignment with an API request and then navigate it to it as a student, at which point we are dropped directly into the student experience working on a particular assignment and can start simply filling it out. And so the student experience gets to very concisely use the same fixture data in order to ensure that we can execute on an assignment that we know now the teacher experience is able to make, and to do so in a way where a failure in the teacher experience's ability to fill out the form doesn't prevent our ability to test whether the student experience can successfully create or can successfully complete their work, essentially. And so after we seed the assignment as prerequisite basically for this test, we then can go through the actual assignment just by clicking on the various fields and typing in them, filling out our answers, getting the answer correct or incorrect as basically the test itself requires. And that looks like this. So notice here, we don't actually fill out the form at all for the teacher experience. We just make an API request and then we jump straight to the student experience, which takes less time, obviously, than filling out the form. And again, affords us this this better independence of the tests while still letting us ensure that the student experience has the prerequisite assignment data that it needed in order to execute on this test. And so these things together as sort of complementary approaches are how we at Assistments tackle these single view asynchronous tests. Single view meaning that any given test is just focused on one experience, and it will make API requests to seed any data that is a prerequisite, essentially, of that test. And here, for the most part, those that data seeding is done either in a before each hook or at the very beginning of that test, because we have these poll style updates where the application can just load basically whatever was previously generated at the time that the page refreshes. Now, in contrast, we also have a small handful of these multi-view asynchronous tests. And here, the general approach is we're going to test the teacher experience and the student experience in a single flow. We have far fewer of these because we basically use it as a smoke test. Our assertion that like the most business critical functionality is working end to end. The teacher experience and the student experience do work together to create a given assignment and complete it. And so we don't do this for the full gamut of all the different combinations of settings that are possible, but rather for the minimum to ensure that, yes, indeed, like the teacher and student experiences have the connective tissue working together. And what is nice about this from a test maintenance standpoint is that we already have the bulk of the commands, or really all the commands that we need to simply start composing those commands to switch views between our teacher and student experiences. We can just call our create and verify assignment through UI command on a given fixture. And here we have one that is sort of specifically designated to be used across products in this multi-view asynchronous approach. And then we can just get the xref from that previously aliased command, because this will not only get the xref or the identifier of the newly generated assignment in order to verify all its data, it will then switch to it will then alias it, so that we can now navigate to the student experience for that assignment and just start filling out the answers to that problem. And so here in our multi-view test, you can see when we start, we actually do fill out the form, unlike the previous student experience test. And it's sort of a combination of these two things. We fill out the form itself through the UI, then we switch over to the student experience and fill this out as well. And again, this is not generally considered like a best practice in terms of how you would want all of your tests to run, because if there's a failure here, it immediately it begs the question, like, is it a failure in the teacher experience or the student experience? But depending on your organizational needs and the criticality of the sort of connective tissue between experiences, which for us, it's paramount, essentially, that teachers be able to make assignments that students can then complete exactly as prescribed, it may be worth sprinkling some in order to increase your confidence that the connections between your experiences are working flawlessly together. Now with that, let's take a look at a real-time example in Cuddle, which, to remind you, uses push-style updates. So this is like one user makes an update and then immediately the other one can see it. And here we're going to use a single view approach where we're just testing from a single user's perspective. So our general idea is we're going to, for user management, maintain a test-controlled connection. Cuddle uses WebSockets, and so a very straightforward way of maintaining a separate session to use for like an unseen user is to have Cypress control its own socket connection. We're going to make the player moves through the UI, and then all the moves of the opponent, like the other person, through the API using that test-controlled socket connection, which is actually quite simple to do. In our commands file, we just instantiate a socket connection. Cuddle, I should say, uses the Sales.js backend framework, which comes with its own socket client. It's a wrapper around Socket.io, essentially. And so we can just instantiate and connect the socket, at which point we put together a utility for making API requests through that socket. This is just a simple abstraction for making requests. And now we can start to utilize that on behalf of our different users. So the first and main command that we use all over the place at Cuddle.cards is to create a game, essentially, which requires there be two users. Somebody has to make a game, both players have to join it, excuse me, and then both players have to say that they're ready, and then the game starts. And so this walks through that whole process using a combination of making user actions through the Pina store. Like I mentioned earlier, that we expose the game store, for example, to Cypress off the window object. And this lets us basically ensure that we can force the application to do what we want without going through the UI by directly hijacking the Pina store, essentially. And this can ensure like all the side effects of any given action are sort of handled by the application itself. That's just prerequisite. But then we also can make requests on behalf of an unseen user to like sign up an opponent and subscribe that opponent to the game. And then to say that that opponent is ready. So we're using a combination of the Pina store for doing player actions that are sort of the API-driven setup, but with UI important side effects, as well as using the Cypress connection controlled, or the socket connection controlled by Cypress to act on behalf of the other user. The next thing that we need to be able to do is set a particular game into a specific situation. And we do that with a command called load game fixture, which basically inputs an object that describes where all the cards are. These are all the places that a card is allowed to go. And it makes an API request that is a testing only API request, of course, to put the cards where you say they ought to go, essentially. And then we can start to take actions as an unseen user by using that Cypress-controlled socket to make a request to hit the API with a particular move, for example, like to play a card for points. And here we have a suite of basically one command per move or important action that we want the other person, like the opponent, to do, such as playing points. As for validating state, we take basically two approaches, and we concatenate them into this assert game state helper, which on the one hand checks that all of the DOM nodes match the fixture, and on the other that the Pina store just matches the fixture as well, in case there are any cards essentially that are not rendered in the DOM but are relevant, essentially, where we still want to make sure that they're in the right place as far as like the actual data architecture itself. And so putting these together, we can now pretty easily make combinations of moves back and forth. Like we can start a game with a single command, set it into a particular situation so that we can, in this case, check that both players are able to play points. And because this is a symmetrical experience, so both players are in the same client, if we want to check on the one hand that I as the player can make points and see the update process, and on the other hand, when an opponent plays points that I see that update, we can just interweave those pretty easily in a single test by using the UI to select cards, like in this case, the ace of spades, and then to click on the option to play that card for points. And then, and here we're going to make a brief interlude to confirm that we can't actually play the ace of clubs out of turn. This will just verify that if you try to do that, you get an error, essentially. And then we can assert the game state after any step, including these making a player move, an error player move. And then we can check that the opponent can play points, and the user will see those points. So in this case, the player plays the ace of clubs from, the ace of spades from their hand to their points, which we then assert, here. And then the opponent plays the ace of diamonds from the opponent's hand, their player one, ace of diamonds to the opponent's points after. And putting all that together, it looks like this. We quickly start a game. Then we set that game into the specific situation, play the ace of spades, try to play out of turn, get an error. Now the opponent plays the ace of diamonds, and at each step we're able to validate that we see exactly what we want, both in the DOM and in terms of the data. Okay, so we're very tight on time. Altogether, I hope this has been helpful for framing your understanding of how to approach multi-user testing, and that if you take one thing away with this, it is to start with a thought about what your approach wants to be, what you're going to mock, what you're going to seed, and what that means about your risks and assumptions. And that this positions you to create a system of user management that is generalized to then let you start abstracting the common operations and assertions into utilities that help you to test multi-user flows. Hope you enjoyed this talk.
Hey, Ryan, thank you so much for this session. It's so easy to learn when we're learning cuddle cards. That game is, I put this in chat, but it absolutely dominates my family's game nights now. In seriousness though, about your talk, real-time testing can definitely feel chaotic, but you made it look both practical and possible. I know we have a question from the audience, so I'd love to bring that up for you. So I'm going to go ahead and share that. What would you say is the biggest difference between testing a regular application versus testing a game, if there is any?
So one thing that's quite nice about testing games when they're web applications is often you have a very singular definition of state that is most of what you need. And so that has made it really streamlined when we look at like loading a particular fixture for the game and then creating and then doing moves and then asserting that the game has the same state. Most of the combinations of like obscure edge cases and situations where like there's a jack as the last card in the deck and then somebody plays a 7 and that lets them try to play the top card, but they can't because you can't play a jack in this situation. Those sequences are all like very describable through a central piece of data as like the most important source of truth. And that really streamlines a lot of your testing infrastructure, which means that if you put the work in to get a robust way of quickly getting into the game and quickly putting the game into whatever situation you want, and then making an assertion that the state matches what you want, you get this really expressive system that covers almost everything that you need. Whereas in other applications, there's more likely to be sort of ancillary things, and there's a bit of like putting finger in the dike to make sure like, oh, and can I test that, and can I test that? So that's one thing I quite like about testing games.